So now we're looking at an inequality with rational expressions in which we have rational expressions on both sides of the inequality and multiple rational expressions on one side. We might eventually get to the point where we have them, multiple on both sides. Right now, our goal is always to get it in the form of some rational expression of x. So some expression of x and some expression of x, and that includes a constant, and then less than 0. That's our goal, is to get to just one rational expression on the left-hand side and then 0 on the right-hand side of the inequality. So how we do that is, when we have this form, we need to look at getting everything over the least common denominator. So first, let's move everything to the left-hand side, which gives us 1/2 plus 4 over x squared minus 3 over x, and that's less than 0. So what's our least common denominator? Our least common denominator, we have 2, we have x squared, and we have x. So we need a 2, and we need x squared. So our LCD, our least common denominator, is 2x squared. So we need to get this over that least common denominator. So what is it that we're missing with 1/2? We're missing the x squared. So we'd multiply 1/2 times x squared over x squared. Plus, with 4 over x squared, we're missing the 2, so we'd multiply this by 2 over 2. And then with 3 over x, we're missing 2 and x, so we'd multiply this by 2x over 2x. And that's still less than 0. So now we put it over the least common denominator. It gives us x squared over 2x squared plus 8 over 2x squared minus 6x over 2x squared, which is less than 0. And then putting them all over the same denominator, we get x squared minus 6x plus 8 all over 2x squared is less than 0. Now we need to look at, will the numerator factor? So do we have two numbers that will multiply to positive 8 and add to negative 6? Well, that would be negative 2 and negative 4. So x minus 2 times x minus 4 over 2x squared is less than 0. So now we find our critical points. Our critical points are where this rational expression that we found on the left is either equal to 0 or undefined. So first off, it's equal to 0, so we'll write down zeros when the numerator is equal to 0. So we have x minus 2 equals 0, or x minus 4 equals 0. That gives us x equals 2, or x, that was supposed to be a minus, x minus 4 equals 0, so x equals 4. And then we also need to look at where it's undefined, and that's when the denominator equals 0. So 2x squared equals 0 when x equals 0. So there are our critical points. And now we go ahead and line everything up just like we normally would on our number line. So let's write down our critical points. We have x equals 0. That's where it's undefined. And then 1, 2, 3, 4, we have x equals 4, where it's equal to 0. And then we have x equals 2, where it's equal to 0. So that breaks this up into the following intervals. We have, for our intervals, from negative infinity to 0, from 0 to 2, from 2 to 4, and from 4 to infinity. So we will test a value in each one of those in our found expression. And again, you can set this up where you have, is the numerator in this interval, is this factor positive, is this factor negative, is the denominator positive or negative, and then find their product and quotient. My preference is I'll just test a point in each one of these intervals. So from negative infinity to 0, I will test x equals negative 1. So let's test it in our interval negative infinity 0 at x equals negative 1. And with this method, we can use what we originally started with, or we can use what we found. I'll go ahead and use what we found, since we can just label the intervals that way. Then you could use the other method as a check if you wanted to. So at x equals negative 1, we have negative 1 minus 2 times negative 1 minus 4 over 2 times negative 1 squared. That's going to equal negative 3 times negative 5 over 2 times 1 is 2, which equals 15 halves, or 7.5. So that is not less than 0. So this does not check, because this is positive in this interval. Now in our next interval, 0, 2, I will pick x equals 1. So x equals 1. When we substitute that in, we get 1 minus 2 times 1 minus 4 over 2 times 1 squared, which gives us 1 minus 2 is negative 1, 1 minus 4 is negative 3, over 2 times 1 is 2. That equals 3 halves. So that's positive as well, so that's not going to work. 2, 4. On that interval from 2 to 4, let's just go ahead and use the middle. X equals 3. So with x equals 3, we have 3 minus 2 times 3 minus 4 over 2 times 3 squared, which equals 1 times negative 1 over 18, which equals negative 1/18. So that's going to be negative. That does satisfy our inequality. And then on 4 infinity, I'll go ahead and use x equals 5. So we have 5 minus 2 times 5 minus 4 over 2 times 5 squared, which equals 3 times 1 over 50, which equals 3/50ths, which also is positive and does not satisfy the inequality we found. So this means that the only interval that satisfies our inequality, based on the critical points that we found and checking between those critical points, is the interval 2, 4. So that is our solution for the initial inequality. 1/2 plus 4 over x squared is less than 3 over x. And again, if you wanted to check, you could take and test each interval in the original inequality as well, and verify that it's a true inequality only in the interval 2, 4.